Hello, welcome to Chapter 9, Section 1, where we're identifying quadratic functions. We're working on page 594 of the book. If you're looking at the PDF, that's actually page 9. And we're going to do problems 2, 3, 4, and 5, where the directions say, tell me if this function is quadratic. And the important part right there, explain. Explain why or why not. All right, so let's look at these problems. Two of these are written as function equations. All right, I got to change these in order to put them in standard form, and I don't like it with the x and y that way, but that's just my problem. And then for these two, which we'll do in a second, we're going to have sets of data. All right, so what I know if I have an equation, I need to look for x to the second power. And if I have anything higher than x to the second power, then it's not quadratic. I have to have that and nothing higher. So let's put this in standard form. This 6x needs to go on the other side. So I add negative 6x. And I get y equals negative 6x subtract 14. So do I see an x to the second power? No. This is not quadratic. Why? Because there is no x to the second power. That's it. Nothing more I need to explain that. Let's look on this one. Again, I don't like it when they put y with other stuff. It's bad. I'm going to put that negative 2x squared on both sides, which is going to move it. And I get y equals, put them in order, negative 2x squared plus 3x subtract 1. Is this quadratic? I see an x to the second power, so that means it could be. If I have x to the second power, why would it not be quadratic? Well, do I have x to the third power, or x to any power that's higher than 2? I don't. The only other exponent I have is the hidden 1 that's on the x to the first power. There's also a hidden x to the 0 power here, but don't worry about that right now. So because it has x to the second power, yes. And when I explain, it has x to the second power and no higher power, if you want to say it that way. Technically, it's no higher power on the variable, but that's okay. All right. In this same section, we talk about finding if quadratic functions can be found from tables. All right, so let's look at the x's first, just to make sure they're not messing with us. Negative 4, negative 3, negative 2, negative 1, 0. Each of these are going up by the same amount, which is plus 1. So I have to check. I have to check that I have constant change in the x's. And like I said, for the ones that I'm going to give you, the ones that I'll write, this comes from the book, I will make sure that that happens. I don't want to confuse you. Because what I really want to look at is what's the change from 39 to 18. Now from 39 to 18, the numbers are going down. 39 subtract something is going to go to 18. What is it that I'm subtracting? All right, so what's the difference? 39 minus 18 is 21. So if I do 31 subtract 21, I'm going to get 18. So from 39 to 18, I went down 21. And if you don't believe me, you can check it. Clear. 39 subtract 21 equals 18. Now, what about from 18 to 3? This is going down 15. 18 subtract 15 equals 3. What about from 3 to negative 6? Well, think about it as a number line. From 3 to 0, that's down 3. And then from 0 to negative 6, that's another 6. So in total, I'm going down a total of 9 units. And from negative 6 to negative 9, I'm going down 3 more units. Negative 6 subtract 3 more equals negative 9. All right, so these are not the same. So what I know so far, the only thing I know so far is that it's not linear. but that would have been in a different chapter. Now I need to find the second difference. Negative 21 to negative 15, that's actually going up. How far up? It's going up by 6. Negative 21 plus 6 is negative 15. Negative 15 to negative 9 is also going up by how much? Also 6. Negative 15 plus 6 is negative 9. Looks good so far. Negative 9 to negative 3 is also going up. One more time, it's going up by 6. So this second difference is constant. So yes, this is quadratic. And one thing I want to point out, just this has nothing to do with this problem, but it says something earlier, and this is an example of what to look for. When we did tables earlier, I said you can always see some symmetry. I can't see some symmetry here. Why? Because I don't have enough of the table. If I continued this table and like did x equals 1, x equals 2, x equals 3, I might be able to see that symmetry that I'm talking about. So I just pointed this out as like one of those examples of you don't see it right away, you might have to make more of the table. All right, going back to this. So let's look at the x's. And I don't have to rewrite it as a table like this. From negative 10 to negative 9, that's plus 1. From negative 9 to negative 8, that's plus 1. Negative 8 to negative 7, that's plus 1. And negative 7 and negative 6, that's plus 1. So the x's are okay. Let's look at the y's. 15 to 17, that's plus 2. 17 to 19, that's plus 2. 19 to 21, that's plus 2. 21 to 23, that's plus 2. Those are all the same. So the answer is no, this is not quadratic. This is a linear function, or I could graph it into a linear function. There are points that could be on a straight line. Now, before I stop this video, I just want to mention, because this has come up in class, well, what happens if you find the difference? 2 to 2 to 2 to 2, that's 0. 0 would all be the same. Okay, so we got to make a little side explanation. The second difference has to be constant, but not 0. If the second difference is 0, that meant that the first difference was constant, which meant that it was linear. Okay, so I know that if you could overthink it a little bit, don't overthink it. We'll see you in the next video.